All right, so we're just finishing up this this particular example. We're just looking for the angle. So we're going to have tan inverse of our y component over the x component. What we're finding, remember the relative velocity is for people that are standing on the side of the river. So if I was standing on the side of the river watching this, or I guess not on the conveyor belt, if I'm sitting here watching this person on the conveyor belt, the way I view them, I would see this person moving, so therefore the person is moving at 0.52 meters per second, and the direction here would be east, 73 degrees north. So the runner is heading in this direction, but he's actually heading in this direction when you're watching from this vantage point here. And for the runner as well, really the runner is constantly facing north. So if you were if they're doing this at night when there's no lights around them, they wouldn't realize that they've actually traveled this distance along the x-axis. So that's what relative motion is. It's watching the person think they're moving one way when they're really moving another. So same conditions as the previous example. What happens if the runner has to finish directly north? So life depends on it. We want to determine their heading, relative velocity, and the amount of time it would take to cross the conveyor. So the situation now, conveyor is still moving to the right. Person, the runner, can head north, but we want to make sure we end up over here. So from kind of using your instincts here, that means that the runner would have to actually aim in the direction or run into the conveyor, if you want to think of it that way. So that is what we want to know, and this is the original direction. So we're really looking for VA because we want this, or this now becomes our resultant, or V relative. All right, so for people that are taking the 3U course is pretty fresh. Remember we talked about resultant equals vector U plus V all the time. Very similar here. We're just identifying, we've renamed our resultant to relative velocity and VA plus VB. Okay, so very similar concept. So if you're sitting there saying, what's the difference from last semester? There really isn't. It's the terminology where the difference lies. So that being said, if we know what the relative velocity is going to be, we got to find A. So that means that we're going to use our algebra skills here. We know VB, the conveyor. So we subtract VB from both sides. So we end up with, we take our relative velocity, we minus or subtract the conveyor, and that will get us the direction we need to head. So we're just going to simply use our stacked vector notation that I used in the grade 11 course, and that we talked about in the previous lesson. Relative velocity, excuse me, I don't want to be heading left or right. I want to be heading straight north. Oops, should be J. I was going to put meters per second. So J. Now VB, it hasn't really changed. It's still 0.15I plus 0J. And this is going to give us, this will give us the direction and heading that this individual needs to run. So we end up with negative 0.15I and 0.5 take away 0, still 0.5J. So some of you are going to be saying, well, I figured that already. That I didn't really have to do all those calculations. Keep in mind, for scenarios like this, it's easy maybe for you to predict, but you still need to be able to see where it came from. So when you're into a situation that isn't common sense, you know how to handle it. So A part wants the heading. So tan inverse of the 0.5. And again, I don't need the negative in there, all right, because I know the heading will be, we're going to head negative, so it's going to be west, 73 degrees north. What's relative velocity? So B part relative velocity, we're just looking for the magnitude here. All right. Yeah, we're just looking for the velocity. I'm not sure I really like the way that's worded, but it is technically the relative velocity as you run along there, and that's just taken from the square root of your x component squared plus your y component squared, which is the same as previous example, which was 0.52 if I remember. So therefore, it's 0.52 meters per second, and I'll put the direction in because we were talking about velocity. And the final one is how long is it going to take the person to cross the conveyor belt if they run that way? Okay, well, it doesn't matter at what angle you run. If you are running at 0.5 meters per second that direction, then it's going to be the exact same as it was in the previous direction. As long as your y component or that component heading north never changes, then this formula will never change. So v delta t. So displacement, it's 400 meters across the conveyor belt no matter which angle you take. And if you were running at that velocity, that y component velocity, you are running at 0.5 multiplied, or finding your delta t. So we end up with a delta t equal to 800 seconds. So therefore, it still takes 800 seconds. And the reason for that, I'll stress it one more time here, the reason for that is because your velocity, the y component, if you want to think of the y component, or your velocity heading north never changed. It's 0.5. So even if you're heading this angle or this angle, if that vector stays the same, it's still going to take you 800 seconds to cross that same length. All right. So there we are on that one. So our final example, plane leaves Mitchell Airport. Relative velocity of the plane is 250 kilometers an hour, north 25 degrees east. If there's a wind blowing from north 50 degrees west at 50 kilometers an hour, determine the original heading of the plane. And I don't know why it's a question mark. Determine why the original, what is the original heading of the plane? So anyway, fixing my grammar. Now, people who are fresh out of the 3U course are going to say to themselves, well, did we not do questions like that? Yes, you did. I just passed them off as vector questions to get you ready for this. But you're right, this is the exact same as the homework from 3U. This is the formula I gave you. I said, oh, the resultant is always U plus V, U's the plane, V's the wind, R's the resultant. I'm just changing your notation now. So instead of a resultant, it's now your relative velocity equals velocity of the plane, and you can use VP plus velocity of wind. So yes, it is exact same as last semester or the previous year with the 3U course. We're looking for velocity of the plane. I'm going to subtract velocity of wind from both sides, meaning that my relative velocity minus velocity of wind equals, oops, I'm changing notation. Oh, I guess I had VW anyway, equals velocity of the plane. So again, I'm just changing your notation. Nothing really is changing other than your notation. So relative velocity is 250 north, 25 east. Please remember, you cannot use that angle. It has to be with the x-axis. So I think that would be 65. And that's the 250. Remember, wind, if you're standing at the origin, it's blowing in my face from north 50 west. So it's coming in like this, which means it's actually blowing over here. So there's the 50. So I'm going to use the 40 degrees, and it is magnitude of 50 kilometers an hour. Should be kilometers an hour. Now we're all set. We'll use that stack notation. So relative velocity equals, so it will be 250 cos 65i plus 250 sine 65j minus velocity of our wind, which would be 50 cos 40i minus 50 side 40J. Doing our calculations, we can find or determine our VA in this case, magnitude of the plane. So I'm just going to add, like we did the other day, those columns. Just be careful with that sign out front. So with the calculator we get 67.4I plus 258.7J. So we want to know heading, the original heading, so we need to know a bunch of information here. So I need to know magnitude of your VA, 67.4 squared plus 258.7 squared, all square rooted. So we plug that in, plus the 258.7 squared equals square rooted. I get it's called 267 kilometers an hour. My direction, tan inverse of the 258.7 over 67.4. When we get that angle, divided by 67.4, tan inverse, and it's 75 degrees, let's call it. So therefore, the plane must have headed. So when they took off, the pilot set the settings, set the throttle for 267 kilometers an hour airspeed, and was heading east 75 degrees north. So that's what the plane was doing, or what the pilot set the plane to do. But in the end, that 250, this is what the plane is actually doing. So mathematically, it's the same as what you did last semester in the 3U course. And that's where you leave it. So relative motion is kind of taking the place of our resultant vector. So I'm just changing your terminology and moving you over from one to the other. Here's the assigned homework. Oops, give it a try in class. If you're comfortable with the vectors, it should go very well. If you have any questions, let me know and we'll get them all cleared up. Good luck.